Your OpenAPI endpoints handle arrays, but how do those translate into actual API calls when AI models try to use them? You'll see exactly how FastMCP serializes array parameters, whether they're in query strings or path segments, so you can predict and control how your API behaves when called through MCP. The examples will show both the default explode behavior and the compact comma-separated format, plus how path arrays always use a consistent style.
Hash query array with explode equals true, default. Hash tags equals red and tags equals blue and tags equals green. Hash query array with explode equals false. Hash tags equals red, blue, green. Hash path array, always comma separated. Hash items red, blue, green.
This demonstrates the OpenAPI to MCP transformation pattern, where REST API specifications are automatically converted into AI callable components. The technique bridges the gap between traditional web APIs and modern AI tooling ecosystems, preserving the original API structure while adapting it for LLM consumption. What makes this distinctive is its dual-layer approach. Semantic mapping of HTTP methods to appropriate MCP component types, combined with parameter handling that respects OpenAPI's serialization rules. The pattern operates through declarative route mapping and progressive enhancement. First, it analyzes the OpenAPI spec to categorize endpoints into tools, resources, or templates based on configurable rules. Then it applies systematic parameter transformation, handling query arrays with explode semantics, path arrays as comma-separated values, and automatic null filtering, while maintaining the original API's behavioral contracts. This separation between structural mapping and parameter processing creates a clean adaptation layer that doesn't require modifying the underlying API. The value lies in rapid AI integration without sacrificing API design integrity. Developers gain immediate LLM accessibility for existing APIs while maintaining control over exposure through route filtering and component customization. This approach excels when modernizing legacy systems or creating AI gateways, though complex APIs may still require manual curation for optimal LLM performance. The trade-off between automation convenience and semantic precision makes this ideal for prototyping, while production systems often benefit from selective manual component design. Let's break it down line by line.
Hash query array with explode equals true, default. Hash tags equals red and tags equals blue and tags equals green. Hash query array with explode equals false. Hash tags equals red, blue, green. Hash path array, always comma separated. Hash items red, blue, green.
These examples demonstrate OpenAPI array serialization formats for query and path parameters. The first format shows exploded query arrays, where each value gets its own key-value pair, standard for most APIs. The second shows comma-separated arrays in a single query parameter, useful when URL length is constrained. Path parameters always use comma-separated arrays, since path segments can't repeat like query parameters. URI template patterns. FastMCP's URI templates bridge static paths and dynamic parameters, enabling both path variables and query parameters in a single declarative string. Query parameters automatically coerce string inputs to your function's type hints, but this magic fails silently with complex nested types. The template syntax you define becomes the public API contract. Design it intentionally, not as an afterthought.
The URI that names everything becomes nameless when it names itself.